Okay, let's continue with this on doing the analysis of the data that we just extracted from our database. We now have our 24 genes that were in rows as 24 columns. And in yellow we have treatment group 1, and in red we have treatment group 2. So the first thing I'm going to do will help us here, but it'll also prepare us for do an insert, and then shift the cells to the right, and this will be treatment group ID, right? And actually I need it down here. 1, 1, 1, 1, 1, or it can be a word, 2, 2, 2. It could be control and drug. I'm just going to do anything that'll label them. So what we're going to do is we're going to just examine one of them in Excel, and then we'll go into JMP to do the t-test on many of them. We come to data analysis, our 2 t-tests assuming unequal variances, and variable range 1. Okay, and then 2. So treatment group 1 versus 2. Notice I'm not clicking labels because I didn't pull them in. Our alpha is 0.5. I don't have a hypothesized mean difference. Let's see what's going to happen there. And our output range, I'm going to put it down here. And go. Okay, so I got a mean of variable 1, which would be the first set, 10, and then the second is 11, so this is not going to be statistically significant, right? And because I remember there was an actual sample size of 9 in the original group, and I picked the first 10, so actually only this specimen down here is from another experimental group. This first 9 are all from the same experimental group, so what's my range within those? They look okay, but that's what we're searching for. Is there a difference, and do we have a large enough sample size to determine that? So this could be a pilot study that would give us our mean and our variance, right? That's standard deviation squared, so we take the square root of this, and that would be our standard deviation. We would have 2 numbers getting us ready to do our power analysis and estimation of sample size to get a statistically significant difference. How large would our sample sizes have to get before the little difference that there is between these two? Not much, right? 0.4, 0.5, something like that. So not a big difference. So our sample sizes would have to get very large to get a statistical significance there. Well, what if we want to do the same thing for all of them, right? Remember, so I did 24. Let's say we're just going to do 10, and we set our p-value p at originally at less than 0.05. That's our alpha, right? I can insert the symbol. Do I have alpha here? Okay, and then our beta. I'm just doing this to show you how to put symbols in here, kind of showing off, but anyway. And let's say our beta, remember, is what it's on p, but anyway, say 11%. Sorry about that. So this is what we're kind of playing with. That's why we're getting this data that might be very close, or we don't know, and stuff like that. So now to get this set for JMP, what we need to do is just let's get, all we need is this here. We don't need that top row. Hitting the shift button, holding it down, and right arrow takes me all the way out. I'm going to copy that. Need to go to a new sheet. Actually, I don't for jump. Let me show you why. I can press escape and it undoes that. We just can't have a blank in here, so take that out, and we select our table again, shift and right arrow, and then we go here to JMP, set our preferences, and it's just going to let us set our table name. It wasn't this. Here's where we want to remember what our GSE was. I'm going to make one up. 687543 and it was, let's see, I have a glioblastoma, right? So this is going to be the table name in JMP. First rows as column names, right? If they were classified differently, say these were titles up here, to assign them to another group, like gender, male, female, something like that, we'd have 2 rows, but we only have 1 here. So there might be different things you can do, but right now we've got 1 header, 1 row with the headers in it, and we're sticking with that. Okay, and now we go to this one here, JMP data table. It's going to open JMP and pull it into there. So I haven't done a t-test in JMP yet. Let's see if I can just figure it out intuitively, right? In case you suspect I'm not going to be able to get it right within the recording time here, you might want to go and do a search. Okay, so there's all our stuff for JMP. It's pulling up other things that I asked it to run before. I think I can close all these. Oh, wait, well, that's my new table. Okay, don't want to close that one. This is the help window. That one will be okay. Got this one, and this is my new data table. Okay, one of my previous ones, I'd saved it to where it'll run the script, rerun the script whenever I open it, so I didn't want that to happen. Okay, so this is all we're working with. This is our data table here. You can see if I scroll over, I've got all of my columns. I've got all of my rows, right? 2 sets of 10. And my treatment group 1 and 2 are going to tell it that that's what's going on, right? So it's recognizing the treatment group as numbers, the gene symbols as what's it doing over here? If I click on this, as nominal, right? And it's treating this as continuous. Okay, so we got all of our rows. Now let's see if we can analyze, I guess, X by Y. We could do a help. Bivariate. Yeah, the bivariate is just a t-test, I think. So what we want up here, our response, this is our dependent variables, so I'm going to put all of them in there. So I did clicked on the first one, shift, hold the shift and down arrow. Then the X factor is just going to be my treatment group, right? And so it tells me it's going to do a bivariate analysis, right? Only 2 columns. It found only 2 classes of values in here, numbers 1 and 2. If there were words, it would be the same. And I click OK, and I should have, it gave me graphs on each of those. Let me pull this down. Then we click on this little thing here, and what did it do? This didn't do a t-test, did it? It did something different. Okay, I didn't do the right analysis. Okay, so I got that one wrong. That's attempt 1. How many attempts are you going to give me here? Distribution? There's got to be a way of doing the t-test here. Let's try it again. Treatment group for the weight and by. That says optional. And then these here, Y. Let's see what that'll do. Okay, that gave us our descriptive statistics. We got a distribution. It's probably median. Got our median and quartiles. our mean, standard deviation, error of the mean, upper and lower 95. We got a 95% confidence intervals. Got it for distributions of group 1 and group 2, right? Group 1 and group 2, but did it do a t-test? This gave all of our distributions. Okay, we're not there yet. I could have done a help search, but anyway, we're just playing with it to see what we can get. This gives us our descriptive statistics, our graphics, and very quickly, group 1 and group 2, if we expanded our window and everything, you can do a comparison. Mean and median are very close. Mean 1, we already looked at that one, we know it isn't significant. Mean 9.2, and this our standard deviation, so those are not going to be statistically significantly different from each other. Okay, so that didn't give us what we wanted in jump. I keep saying JAMP. Matched pairs. Well, let's try that one. Okay, X grouping, that'll be our treatment group. And then the Y paired responses. Let's do. The following columns are not nominal or ordinal, indicating a possible mistake. Please consider canceling unless you're sure this is what you intended. Right? So the grouping, because it's a number, if they were words, it would like that better. To all possible pairs rather than separate pairs? Why not? I don't know what I'm doing. Let's see what it gave us. DDR1. So, okay, first part is our gene symbol. I don't know what it did here. Degrees of freedom. Okay. What did it compare it to? Oh, I told it to compare all of them. Oh, I see. Yeah. So it's comparing DDR1 to every other one of them, right? But here's where we're going along. So we got a mean difference, standard error, our confidence intervals. Is 0 in between these two? No. So then we have a pretty good confidence. Wow, this is when you realize there's more that you don't know than what you do, huh? Treatment group 1. Okay. Not quite sure what it all did up there. Maybe that's just more information. Treatment group 1 and 2. Obviously, there's not going to be any significance there. Mean difference. We got our F ratio. Okay, I'm just going to stop. There's more that we need to learn. And anyway, what you're able to see here is that in JMP, once you know what you're doing, clicking the right buttons, you can analyze all your samples, all the variables at once, rather than the one at a time that I seem to be doing with the Excel. Okay, we'll refine this and do a better job once I've figured out exactly what to do. Thanks for sticking with it.